Hello everyone. In this lecture, we'll discuss about the losses as well as the power flow in a three-phase induction motor. So first we'll discuss the losses. So we have two different losses in the case of induction motor. First one is constant loss or constant losses, and second one is the variable losses. So first we'll discuss about the constant loss. So constant loss are broadly classified into two different types. First one is the core losses. Okay. So this core loss comprises of both the stator core loss as well as the rotor core loss. Okay. And the second one in the case of a constant losses are the mechanical losses. So in the case of mechanical losses, we have frictional losses as well as the windage losses. Okay. So in constant loss, we have two different losses. One is the core loss, another one is the mechanical loss. Core loss comprises of both the stator core loss and rotor core loss, whereas the mechanical losses comprises of frictional losses and windage losses. So first we will see the core loss. So the core loss mainly occurs on the cores of both the stator as well as the rotor. So this core loss is also called as iron loss. Okay. So this core loss mainly depends on the frequency. So this core loss comprises of eddy current losses and the hysteresis losses. Okay. So this eddy current losses can be minimized or eliminated by laminating the core. Okay. So core is laminated in order to prevent eddy current losses, and the hysteresis losses can be minimized by choosing high grade silicon steel. Okay, so both the losses depends on the frequency. So if we take the case of a stator, the stator frequency is nothing but the supply frequency F. Okay, whereas the rotor frequency under running condition will be equal to the slip times the supply frequency, that is Fr is the rotor frequency under running condition. This Fr is very lesser than the supply frequency. Hence the rotor core is negligible. Rotor core loss actually is negligible because under running condition the rotor frequency is very lesser than the supply frequency. So if we take the core loss, we have only stator core loss. Okay. So next we'll see the mechanical losses. In mechanical losses, we have frictional losses and windage losses. So these frictional losses mainly depends on this. These frictional losses occur on the bearings of the motor. Okay. So these mainly depends upon the speed of the motor. As the load changes, speed changes. Whereas the variation in the speed is very lesser, and hence the frictional losses are also considered as a constant losses. Okay. So since the speed variation is very less, this frictional loss is also considered as a constant loss. So thus in the constant loss we have stator core loss plus frictional loss plus windage loss. Okay. So why? Because here the rotor core loss is neglected because the frequency of the rotor under running condition is very lesser as compared to the supply frequency. So next we'll see the variable loss. Second type of loss is the variable losses. So the variable losses comprises of the stator copper loss as well as the rotor copper loss. Okay. So as the load varies, so say for example, if the load is increased, so the current drawn from the supply also increases. Okay. So as a result, the current flowing through both the stator as well as the rotor varies or increases. As a result, the copper loss also varies. Okay. So the rotor copper loss in general is given by 3 into I2R square into R2, where I2R is the rotor current under running condition and R2 is the rotor resistance. So the variable losses comprises of stator copper loss and rotor copper loss. So next we discuss about the power flow in a three-phase induction motor. So in general, three-phase induction motor converts electrical input, electrical energy into mechanical energy. Okay. So the process of conversion of electrical energy into mechanical energy is defined as the power flow in an induction motor. Okay. So first, electrical energy is given as a input. Okay. So the net electrical input power will be given to the stator of the induction motor. So the net electrical input power is initially given to the stator of the induction motor, which is nothing but P suffix in. Okay, input power given to the motor. So now a part of this input power should supply the stator losses. Okay, so this power should supply the stator losses. So the stator losses includes both the stator core loss as well as the stator copper loss. Okay, so now this input power minus the stator losses, that is the power which is remaining. Okay, this is fed to the rotor. So this is the rotor input power, which is denoted as P2. P2 is given by the net electrical input power minus the stator losses. Okay, so now this P2 has to supply the rotor losses. So in the case of rotor, we have already discussed rotor core loss is negligible, and in the rotor we have only the rotor copper loss, which is denoted as PC. It is given by 3 into I2R square into R2. Okay, in rotor we have only the rotor copper loss. Okay, so now the input power has to supply the rotor copper loss. So we have the rotor power, input power minus the rotor copper loss, which is the mechanical power. Okay, which is nothing but the gross mechanical power developed in the motor. So gross mechanical power developed in the motor is given by the rotor input power minus the rotor losses. Okay. So again, this mechanical power which is developed in the motor has to supply the mechanical losses. Okay. So mechanical losses already we have discussed, which comprises of both the frictional losses as well as the windage losses. Okay. So the power PM minus the mechanical losses will be available at the shaft of the motor. Okay, this is the output power which is available at the shaft of the motor. So this is also called as the shaft power. Okay, so initially an electrical input is given to the stator. So this has to supply the stator losses. So the electrical input power minus the stator losses will be given to the rotor. Okay, this is represented as P2. P2 is nothing but the rotor input power. Now this P2 has to supply the rotor losses, which is nothing but the rotor copper loss, because rotor core loss is considered as negligible one. So this P2 minus PC, which is the remaining power PM, is nothing but the gross mechanical power developed in the motor. Okay, again this power has to supply the mechanical losses. Now this gross mechanical power PM minus the mechanical losses will give you the net power output. Okay, or this is a useful power which is available at the shaft of the motor, or power output or shaft power. Okay, so now we'll draw the diagrammatic flow of this power. So first, in the stator we are giving the three-phase supply. Okay, so this is the electrical net electrical input power. Okay, represented by Pn. So this is nothing but the stator. So in stator, we have the stator losses. Okay. So stator losses comprises of both the stator core loss as well as the stator copper loss. So this stator input power Pin minus the stator losses is given to the rotor. Okay. So this P2. Okay. P2 is nothing but the rotor input power or stator output power. Okay. This is given to the rotor. So again, rotor has to supply the losses, which is nothing but the rotor copper loss, because in rotor we have only copper loss. So it is has to supply the rotor copper loss, which is represented as PC. Okay. So again, this P2 minus PC will give you the mechanical losses PM. So this PM has to supply the mechanical losses. Okay. So here mechanical losses are friction and windage loss. So this PM is nothing but the gross mechanical power developed in the motor. Or the rotor. Okay. So this PM minus this losses will be given to the load, or will be the power which is available at the shaft of the motor for doing the useful work. So this is nothing but the power output. Okay. So now the efficiency. So if we define the term efficiency, so we can define the efficiency of the rotor as well as the motor. So now the efficiency of the rotor is rotor output divided by the rotor input. Here the rotor output is nothing but the gross mechanical power developed. Okay, gross mechanical power developed, that is PM, divided by the rotor input. So rotor input is nothing but P2. So PM by P2 into 100 is nothing but the efficiency of the rotor. So whereas the efficiency of the induction motor in overall is given by the output power divided by the input power. So output power is nothing but the shaft power or useful power. Okay.